Welcome to 3.8's Math Moment. Today students worked again with adding and subtracting fractions, but today they worked with fractions that had different denominators that you cannot use the shortcut method for. So if you look back a few lessons, you'll notice that we used something called the shortcut method, where I took the smaller denominator and I was able to times it by something to make the larger denominator, and therefore I only had to change one fraction. Today we're looking at fractions where that strategy is not available, so you have to use a different strategy because that one doesn't always work. So I'm going to show you today with the first example. It says 4 and 4/8 plus 7 and 1/6. So one strategy that students can use is to multiply the denominators by each other. Alright, so the opposite denominator was 8, so I took 6 times 8. The opposite denominator here was 6. So I took 8 times 6. I would have to do the same thing to the top. I would change the fractions and then I would add. Now, the tricky part with this strategy is that you're going to get sometimes larger denominators than you actually need. And in 6th grade, we always want to reduce down and simplify to the smallest fraction possible. So instead of using this strategy, a more sufficient strategy would be to think about what is the least common multiple. So to find the least common multiple, I'm going to list out my multiples of 8 and list out my multiples of 6. So I think 8 times 1 is 8, then that's 16, 24, 32, 40. I always encourage the students to list out 5 to 6 multiples, and hopefully they'll find a match by then. 6 times 1 is 6, 6 times 2 is 12, times 3 is 18, 24, 30. Now, if you notice, I'm going to go ahead and scan and see if I can look for anything that has that is similar, that's the same. 6 and 16. I found 24 that they both have in common. I'm going to check and make sure there's nothing else. Now, what you might notice or be thinking is, well, if you kept going, you would find 48, and that's true. I would find 48, which is what we would have gotten with the strategy before, but the reason that this strategy works a little bit nicer is because you know then it's already simplified, all right, or as simple as the denominator can go. So, using this strategy, I am going to look at 8 times 1, 2, 3 to make it 24, which means I'm going to do the same thing to the top. And I'm going to take 6 times 1, 2, 3, 4 to make it 24. Do the same thing to the top. Now, what I always tell students is, you know that you want your denominator to be 24. You did a lot of work to figure that out. So go ahead and make your denominators 24 right away. Don't even worry about doing that math because you already did it here. 4 times 3 is 12. 1 times 4 is 4. And then I cannot forget about my whole numbers. My whole numbers do not change unless I were to borrow from them, or they'll change when we add. But I don't take them times my numbers. That's only my fraction pieces. All right, so now the denominators are the same. They can stay the same. I'm going to add the tops, 12 plus 4, which gives me 16. And then I'm going to do 4 plus 7, which is 11. Now, if you were using the other strategy, your student might have got the answer 11 and 32 over 48. Now, this answer is the same. They are equivalent. And both of them we actually need to reduce. But working with 16/24 and using this strategy is a little bit more efficient for your student because it allows them not to have to work with such big numbers when they're solving the problem, and also not to have to work with such big numbers when they're trying to reduce it down. I still have to reduce 16/24, which I'm going to use the cake method to reduce, which is just like upside down division. I think to myself, what can I pull out of a 16 and a 24? Maybe your student sees a 4, maybe your student sees an 8, maybe they see a 2. That's why this strategy is so neat, is because students can pull out different numbers and get to the same answer. 4 times 4 gives me 16. 4 times 6 gives me 24. I can keep going. I see I can pull out a 2. 2 times 2 is 4. 2 times 3 is 6. And there's nothing that I can pull out of a 2 and 3 evenly. So this actually reduces down to 11 and 2/3. Again, this answer is not incorrect. Okay, your student could put 32 and 48 into the cake method, and they could pull out and divide that down, and they would eventually get to 2/3, but it just is going to take a little bit longer. If your student chooses to use that method and gets that answer, that is totally fine. Example 2 says, Robert rides his bike 2 5/7 miles on Tuesday, and he rides his bike 2 3/4 on Friday. What was the difference in his bike rides? Well, difference means to subtract, and a little trick we show students is to draw and connect the line and the F's. When you do that, it makes a subtraction sign, and that kind of helps them remember that difference means to subtract. So, the first thing we need to decide is what am I subtracting from what? I've only got 2 numbers here, but I always know that my bigger number needs to be in the front, unless it tells me specifically to do it differently. So I need to first decide which is larger, 2 5/7 or 2 3/4. Well, when I look at these, it's hard to tell because the denominators are not the same. So let's first go ahead and make the denominators the same, which we're going to have to do anyways in order to subtract them. So one strategy that we discussed up here would be to just multiply by the opposite denominator. 7 times 4 and 4 times 7. Do the same thing to the top as you do to the bottom. And now we're able to change them and make them the same. 5 times 4 is 20. 7 times 4 is 28. Then I always bring over my whole number. Then I have 2. 3 times 7 is 21. 4 times 7 is 28. Now it's easy for me to see which one is larger. The denominators are the same, so whatever number is larger on the top is the larger fraction. 21 is larger on the top, so that's the larger fraction. So I actually have to flip-flop this order so I can actually subtract them. 2 and 21 28 minus 2 and 20 28. Now, students sometimes get confused because there are some word problems where you're not able to just flip-flop your answers, or when we have just computation problems where they're set up and one is already in the front and one already comes first. I'm not able just to flip-flop those and make them work. Sometimes I have to borrow. Sometimes I have to use that whole number to help me. But in this case, it's all right to flip-flop the problem and make my larger fraction in front, because I'm just finding the difference of one thing, one person's bike rides. So, 21 minus 20 is 1. My denominator stays the same at 28. 2 minus 2 is 0, so I don't even have to place it as a whole number. And my final answer becomes 1/28 of a mile difference. If you have any other questions about making denominators the same before you add and subtract, or anything on lesson 3.8, make sure to see your math teacher.